Nvidia loses over $500 billion. There's a panic at Meta. Sam Altman's channeling the Patrick Bateman meme.
New card. What do you think?
Woohoo! Very nice. But wait, you ain't seen nothing yet.
Impressive. Very nice.
So why is all this happening? Because DeepSeek R1 just proved open source AI can out-reason the giants. But here's what no one is showing you. How it actually runs on your machine. Today we are testing extremes, a $5,000 M4 Max versus a $1,000 M1 Air. Why? Because whether you prefer to roll with a beast of a setup or you prefer to fly light as air, you deserve to know what's possible.
Nomaditsu.
So there's actually a bunch of ways to run DeepSeek R1 on our computer, but I'm going to recommend LM Studio because I think it's the best mix of ease of use, of power and functionality, and a beautiful interface. To get started, we're going to go to lmstudio.ai and you're going to download from one of these buttons here. Okay, so we downloaded LM Studio, we launched the app, and this is what we see. So next we're going to go to the Discover tab and we're going to type in DeepSeek R1. And when you hit enter, you're going to see all of the different DeepSeek R1 models available to download for free. And now to install it on your computer, you're just going to click on one and then you're going to hit the download button. So I already installed this one. I'm going to look for one that I didn't install yet. So when you click on a model, you're going to see this download button and we're just going to hit download. And you're going to see it downloading in this bar. And once it's ready, you're going to be able to use DeepSeek R1 on your computer. So I'm going to cancel this one because I already downloaded the models we're going to test. And speaking of that, let's cover something about the models you should know about. So what do you need to know about the models? Right here are all the models you're going to be able to run on an M4 Max. And you can see right off the bat, you could run all the DeepSeek R1 model sizes. But with the M1 16GB, you are limited to the 14B and lower. So already we have a winner in the M4 Max 128GB. If you are the type of person that's an AI enthusiast and you really want the ability to run the biggest models and play with the latest AI toys, it's definitely worth it to upgrade if you're the type who gets FOMO and you just really want to unlock all those capabilities, especially if you do video editing, audio editing, image editing. You always have 50 tabs open and you have all of your apps open at the same time. This is a no-brainer because it's just going to run smoothly and yeah, you won't have to worry about that and you'll be able to have access to the best in open source. Now, if you just want to dabble in AI, the other M series chips are actually quite surprisingly capable as long as you get a minimum of 16GB of RAM, which my old MacBook Air has, because I was shocked that it could run up to 14B. So to have a 14B parameter DeepSeek R1 with that level of intelligence, offline, private, and unlimited, it's just shocking that that's happening. Before, when I tried to run models on M1, 16GB RAM, the early models were like, they were crawling, like they were like 1 letter per second. It was insane. But now you're going to see just how fast this could be. All right. So how are we going to test these models? This part of the video took the longest to figure out. So I tested a whole bunch of different prompts, but I landed on one that was simple on the surface. But whenever I tested the models, they went through all of this crazy thinking and it was really interesting to see. Also, it has a definitive answer. So we'll be able to gauge if it got it right or not. I know there's a lot of different things we could test with these models. So definitely comment down below and I'll happily test it out for you guys. But yeah, we want to do a thorough test of all the models. So I had to keep it to just one. And I found a really great prompt. Another thing is, how will we measure the answers? For both of the machines, we're going to take note of, can it reason? So we're going to observe the reasoning tokens, like all of its thoughts. And then we're going to see how fast does it reason. We're going to look at the total tokens it generated, the tokens per second. We'll also look at how long it took to answer. I just updated this equation because I realized it was wrong at the beginning of this shoot. So yeah, it's the tokens divided by tokens per second times 60, which will give us the total minutes it took to answer the question. And then we'll also see, did it get the answer right? And then, after all this, we're going to analyze it all together and make our conclusions. So what is the prompt I selected? So the prompt is this. It looks really simple, but it's actually quite complicated for not only the AI, but for humans. See if you can figure this one out. You have 3 boxes, each incorrectly labeled. One contains only apples, one contains only oranges, and one a mix of both. Now you can only draw one fruit from one box, and then you have to correctly reassign all the other labels. Maybe you want to pause that right now and see if you can figure that one out. A fun fact about this is that this prompt was actually used by Microsoft back in the late 1990s and the early 2000s to test humans in interviews, and it was to test their reasoning. So it's interesting how now we're using this question to test our AIs. So you could see that, even humans could take some time or struggle with this question. This is the prompt, and now we're going to track all of that in Notion. So what I did is I created a Notion template here so we could cleanly track all of the tests. And you could see we're going to do a total of 10 tests, and this way it's going to be easy to analyze the data. So another thing you'll notice here is that, it only goes up to the 14B for testing both M1 and M4 Max. And just as we said before, there's the limit for the M1 16 gigabytes of RAM laptop. It could only run up to the 14B. So for the 32B and the 70B, it's only going to be the M4 128 gigabytes. So that's our testing regimen. Let's get into the tests. All right, before we test, I got to share with you the actual correct solution so we know what we're looking for to know if the answer that the AI is giving is correct or not. And were you able to figure it out? So here's the solution. Okay, so what we're looking for in the answers is that it tells us to open up the mix box first because this is the only solution to the problem, right? So by opening up the mix box, right, we know this is incorrect, and it'll say if it's an apple, that means that, okay, so this is now apples, right? Right? If you draw an apple, now this label becomes apple. That means we know that apple is wrong. So now we could label this orange, right? And then that means we can now change this to mix, right? So it has to get this first step right. If it doesn't say open up the mix box first, and then that will determine the correct answers for the rest of the chain of thought, we know that it's wrong already. Also, it should tell us this optionality, right? If we draw an apple, then that means we need to change apples to oranges, and then oranges becomes mixed. If we drew a orange, right, then that means that oranges is incorrect. So this becomes apples, and then this becomes mix. That's the solution that we're looking for. All right, so let's go on to test. Okay, guys, it's time to test the smallest DeepSeek R1 Distill Qwen 1.5 model. So we're going to be testing from smallest to largest. I'm on my MacBook Air M1, and I've pasted our prompt over here, and let's hit enter. So now I'm going to show you, this is real time, how fast this is reasoning on a MacBook Air M1 with 16 gigabytes of RAM. So what's pretty cool is just how fast it is. Now, is it going to be correct or not? We'll find out. Okay, guys, check this out. This took longer than I expected. The model thought for 9 minutes and 27 seconds. And you could see here just how much thought it put into this answer. But did it get it correct? That's a whole different story. So let's collapse this and look at its final answer. By drawing one fruit from box A labeled apples, we know we cannot have apples, so it must be either oranges or both. So we already know that this is incorrect because it's saying to draw from box A, which is labeled apples. And yeah, if you try to read this, it was breaking my brain when I was trying to read this the first time. I was like, I really couldn't follow. So we know that this is wrong. So despite all of that amazing thought, it was not correct. What we're learning here is that, DeepSeek R1, this is the smallest model. And, the B and the parameters like 1.5B, think of that as brain cells. So the bigger the B, the more brain cells you're going to have, and the more likely you're going to have better answers, the bigger the model you get to. The smallest model, it didn't get it right, but you could see that it could reason. I went ahead into the test log and I inputted the tokens per second and the total tokens, and it gave out the correct amount of time it took to generate the answer, right? So that means my formula in Notion is correct, right? So we have tokens divided by tokens per second times 60, which gives us the minutes it took to generate the answer. And And unfortunately, this was a fail. Okay, guys, we are on my MacBook M4 Max 128 gigabytes of RAM. And you'll see here that I have CapCut open, QuickTime Player, Perplexity, Notion, and I'm still going to run this and it's going to be really fast. Now, another thing I forgot to mention is like when we are running this test, you might want to get the stats app, and I covered this in depth in this video. Actually, this video over here. Okay, so check out that video if you want to learn about the stats app, where it helps you see the performance of your computer while it's doing AI generation on your machine. It's awesome. So let's see this in action. I'm going to hit enter and see how fast or slow this will generate the answers. Okay, so we have our prompt here. Let's go. All right, so I'm going to open this up. Look how fast it's going. And let's take a look at this. The GPU is shot up to 80, 90%. Sensors getting, it's going up in heat. But look how fast it's generating these tokens. And yeah, it's going. This is real time. And I think I could record the whole thing here because of how fast it is. Let's just see how much it goes, right? The M1 took 9 minutes. Let's see how much faster the M4 Max takes. All right, look at this. It's already 60 to 61 degrees Celsius. That's one thing to take into consideration. I have the MacBook Pro 14-inch, and that only has one fan. This will have an effect on how fast your generation speed will be for a sustained period, right? As it gets hotter and hotter, right? Oh, look at this. It's almost 70 degrees, right? If you had a 16-inch M4 Max, I saw in some tests in some other YouTube videos that it was able to stay around like under 50 degrees, and that was able to sustain higher performance. But for me personally, I thought it's fine. I will sacrifice that extra performance for the portability because I'm a digital nomad. I like to go to coffee shops. I like to keep my backpack light. And that's why I went with the 14-inch. And look at this. It's finished the answer. And let's see how long that took. That took 1 minute, 58 seconds. So you could see the performance difference already. So let's note this down in our Notion page. Okay, 126.73. And we generated 14,578 tokens. All right, and we got the correct minutes, but did it pass or fail? So we have here.
Draw one fruit from box C to observe it's an apple. Okay, so since.
Okay, so you could see here, it didn't get it correct. Despite all of this reasoning, unfortunately, it still failed. Let's mark that down as a fail. But what we could take away from here already is we get performance boost in the time it takes to generate that answer, but it doesn't change the correctness of that answer, right? Okay, I'm on my MacBook Air M1. Now let's load up the next model, right? So I'm going to open up a new chat here, and then I'm going to go to the search here, and we will select DeepSeek, and we're going to go to Qwen 7B. Okay, so that's the next level up, right? We're loading up DeepSeek R1 Qwen 7B. This is going to be the next test. We're going to copy our prompt from here. We're going to put it in here, and we are going to execute. So let's see it start up, and it's already thinking. Now you notice this is a bigger model, much bigger, right? In comparison to the 1.5. This is 7B. All right. So it's going to be slower than the original, but still you could see that this is actually decently fast. It's reasonable speed for getting a regular answer, but if you're doing reasoning, this could take a while. So I'm going to pause this and I'm going to come back when it's done. Oh, look at that. So that's different. All right. It took only 41 seconds and it's already giving the answer.
Okay, so all the boxes are incorrectly labeled. So box labeled apples does not contain only apples. Okay, relabel based on the drawn fruit. So if you drew an apple, relabel next to apples. If you drew.
Okay, so there's the summary steps. I should have just went here. Open the box marked apples since it must contain only apples or oranges. Draw a single fruit to determine its true contents. Relabel this box appropriately. Use elimination to relabel the other two boxes. It got it right in 41.75 seconds on a MacBook Air M1. That's amazing. Okay, so let's document this. All right, so this was actually a pass. This is amazing. All right, guys, I'm on my M4 Max. I have a new chat loaded. I have Qwen 7B loaded. Let's take a look. All right, so it's reasoning. Let's see how long it reasons. Oh, done already. Okay, so let's see if it got it right. So it thought for 3.62 seconds on the M4 Max. And now let's see if it's right. So identify the box with the mixed fruits is a good sign. So by systematically selecting from the box apples and oranges, you could accurately reassign all labels. It got it right, and it got it right in 3.62 seconds. Just a lot less thinking. All right, so let's check this out. Let's add our stats in here. All right, so what can we gather here? Okay, so we have more tokens. No, we have less tokens. And we have higher tokens per second. So that's the kind of performance boost you'll see. And now let's move on to the 8B. I am now on my MacBook Air M1. I have loaded up Llama 8B version of DeepSeek R1. I loaded up our standard prompt and let's see it rip. Okay. So I'm expecting the same output, but we could be wrong because Llama is a different architecture from Qwen. Qwen is traditionally known to be better at math problems. So you could see here, it looks like it's more wordy. So let's see if it gets it right. Yeah, you know what? This is already, it looks like it's going to be a long one. Because in the other chat, with 7B Qwen, it kind of just got the answer right away. Okay, so this one looks like it might take a while, so I'm going to stop the video and I'll come back when it's done. Okay, perfect timing. I was about to stop the M1 from generating, but it just finished. That was super long. So let's see how long it actually took, but this was getting alarming. It was taking forever. But it's finally getting to a final answer. Let's see if it actually gets it right, though.
Okay, so identify the incorrect labels. Okay, well, they're already incorrect. Determine the mixed box. Okay, this is good. This is a good sign.
Guys, this is wrong. So, surprisingly, the Llama 8B, more brain cells, but it got the answer wrong and it took way long. Let's look at this. It reasoned for 25 minutes and 10 seconds. So let's mark this down. Okay, so I just made a note here that it was surprising that this was very slow. It did tons of reasoning, yet it got it wrong. And the smaller model, the 7B Qwen, actually got it right in a lot less time and a lot less reasoning. So this is probably due to the Qwen architecture. So yeah, really surprising result. Let's see if it's any different on the MacBook M4 Max. Okay, guys, I'm on the M4 Max. I have loaded up Llama 8B, right? And I have our prompt here. And let's go and let's see. Hopefully it gets a better answer, but you could see it's much faster, but it is going into a wordy response. That's different than the Qwen 7B architecture where it got right to the answer. So hopefully this doesn't take too long. I will stop it right now and then I'll come back once it's done. Okay, guys, it's done. And look at all this reasoning. It's actually much shorter than the one on M1 Air. So here's the important part though. It got it right. So number one, identify the mixed box. Draw one fruit from this box. If you draw an apple, it's an apple, and so on. So this got it dead accurate, and it's the same model, just much faster, right? So it did this in 1 minute and 35 seconds. And so let's add this into our mix here. Okay, so I entered in the information for this test, 43.82 tokens per second, 4,355 tokens, and did it in 1 minute, 66 seconds. And what's interesting is it passed on the M4 Max, but it failed on the M1 16GB. So yeah, this is turning out to be a really unpredictable test and really interesting results we're getting here. So let's carry on and let's go for the last M1 test, the Qwen 14B. Hopefully it doesn't take that much longer. Let's check it out. All right, guys, we are on the M1 MacBook Air. This is going to be the last test because this is the biggest model that this computer can handle. As you could see in this bar up here, right in my stats app, it's already at 90% of the RAM used. That's putting a hard cap on going higher in model parameters. If you're upgrading your computer, try to get as much RAM as possible. That will give you more capability to run a bigger local model. All right. So that said, I have everything set up. I have a new chat and we're going to enter in our prompts. Let's go. Okay. So you can see it's taking a little longer to load up because it's really loading up this RAM here, and we've begun. So I'm worried that this is going to take forever because this is going super slow, as you can see here, because this is a massive model compared to the size of this computer. I didn't even think it would be able to handle this, but yeah, it's pushing the limits at 92% of the RAM used. So I'm going to just let this run, and then I'm going to come back once it's done generating. All right, so it's done. By the way, I realized I mislabeled this Llama earlier. So yeah, this is the Qwen 14B running on the M1 Air. So after 15 minutes and 30 seconds, not as bad as I thought it was going to be, thankfully, it finished its reasoning, and let's see if it got it right. Here we go. To correctly assign all labels, draw one fruit from the label mixed, and then if you pull out an apple, label it apples. If you pull out an orange, label it oranges. And then based on that result, assign the remaining labels accordingly. It got it right. So let's add in our data here. 3.81 tokens per second. Let's check it out. 3.81. And we have 3943 tokens. 3943 tokens and 17 minutes, 25 seconds. And it passed. So, yeah, it passed. Let's go on to the M4 Max. All right. I'm back on the M4 Max and I have the Qwen 14B loaded up. We have our prompt. Let's run it. Okay. So you can see it's much faster here. Let's see how long it takes. It's looking more wordy than I expected it would be. So I'm just going to let it run and I'll be back when it's finished. Okay. Qwen 14B on the M4 Max is ready. It's done in 1 minute and 42 seconds. So let's see all of this reasoning. And did it get it right? Select the box mix. Good sign. And the final answer, draw the fruit from the label mix box. And then depending on whether you pull out an apple or orange, you know that that box contains only apples and oranges, etc. So it got it right. And let's add this to the results. So 2563 and 2974, 1 minute, 93 seconds pass. And that went as expected. Okay, that concludes all of the tests that both computers can handle. Now we're going to go into the bigger models here. We're going to check out Qwen 32B on M4 Max and the biggest one, Llama 70B. So that's next. Okay, guys, we are down to the wire here. We have the Qwen 32B loaded up in the M4 Max. Let's run it. Okay, so let's see how it's going. It is going pretty decently fast, right? It's really cool to see how fast it's going. You know, this is, wow. And it's already done. That is cool. Oh man. All right. See that? Beautiful. And look how clear the thinking is here. It's even giving a visual summary here. Okay. So it got it right. And here's the thing, right? We have a bigger model. So you would expect it to run slower, which it does, but it solves it much faster. So it's like you have the bigger brain, you have more brain cells. It can leverage more brain cells to get the answer faster, even though it's operating slower. So let's see how that actually plays out with the token count. So we have 15.76 tokens here. Okay, so we entered the data. Let's go on to the last one and then we'll do a recap of all the learnings here. Okay, we are at the final test. We have the biggest DeepSeek R1 model that you could run locally on the Mac, M4 Max, 128 gigabytes of RAM. And I'll just point out here, look at this. When we have it loaded up, a 70B model, it's taking up 72% of RAM. And the crazy thing is Sometimes I'll be doing video editing in CapCut. I'll have 50 tabs open and I'll be generating images in Diffusion B, and I'll be doing like having answers generated in LM Studio with a big model, and the M4 Max handles it all. You know, if you want to get that kind of performance and you just love to multitask and you want to explore all the different AI stuff, I would recommend it. It is worth the upgrade. Let's run it. Okay, so it's loading up. You can see it's already thinking. Let's see if it gets it immediately or if it takes a long time. Let's let it run. Right now it's looking pretty wordy, but okay, it's looking like it's getting wordy. So I'm going to pause it right now and I'll come back when it's done. All right, guys, the 70B is complete. And look at this. It thought for 16 minutes, 32 seconds, which is in stark contrast to the Qwen 32B, which thought for 11 seconds. So this is where it gets strange, right? But if we look here, did it get it correct? And it did get it correct, all right? So it's saying pick the mixed one, then relabel, etc. Yeah, if you see here at the bottom, if it's an apple, label that box as apples, otherwise it's oranges, and then relabel the other two accordingly. And that's what we wanted, so it got it right. Now let's put this into our Notion page. Okay, so I've entered in the final data. Now I'm gonna group this together and we'll go through the interesting findings here. All right, guys, so I went through the data and I grouped it in 3 different ways. One was by pass and fail. One was to determine insights we could get from how fast it generated tokens, and then insights we could get from which generated the fastest correct answers. So let's start with the pass fail, right? So which models failed? It was the smallest model, Qwen 1.5B, and the Llama 8B. What can we gather from this? The smallest model likely failed because of the small parameter count. When you hear the B, that's like brain cells, right? So that's the parameter count. And the more parameters you have, it's like the more probability of getting a correct answer. And then we have this outlier results here from Llama 8B, where it passed on the M4 Max, but it failed on the M1 16 gigabytes. So what can we gather from this? Okay, so 2 things. One is it's Llama versus a Qwen architecture. And Qwen, from what I've heard, is better at math, and because it's better at math, it's better at reasoning. So that might be why Qwen was consistently getting it right, besides the smallest parameter count. So the other thing we could gather is that, there's just variability in this, and you just have to run it several times if you get it wrong the first time. All right, so next I grouped the data by the device. So we have M1 MacBook Air, 16 gigabytes of RAM above here at the top, and then we have the M4 Max below. And this is going to be helpful for you if you are considering upgrading and you want to see how much of a performance increase you could get by upgrading. So if we compare performance with the smallest model, Qwen 1.5B, on the M1 versus the M4 Max, we could see that the M4 Max was 635% faster, or 7.36 times faster than the M1. And then for the Qwen 7B, it was about 10 times faster than the M1. Then we have for Llama 8B, it was 7.8 times faster. And for the 14B, it was 6.7x faster than M1. And then, of course, the M1 was capped and it couldn't run the 32B and the 70B. So keep that in mind. It averages about 7 times faster than the M1. So if you're considering upgrading to an M4 Max, this is the kind of performance you could expect. Right, so next I wanted to analyze the shortest time it took to get a correct answer. And what's really interesting is that we got a time of about 2 minutes from Qwen 7B on the M1 Air. And this is impressive because this is a very similar time to the M4 Max Qwen 14B answer, which is 2 times bigger, and it's faster than the 70B, right, over here on M4 Max by 8.7x. So it's really astonishing the kind of intelligence you get from a 7B parameter model, and even the performance time that you get on a MacBook Air, right? 2 minutes. Of course, it's blazingly fast if you go on the M4 Max where it's 0.18 minutes, but really quite impressive considering that running this on an M1, 16 gigabytes of RAM, and it's like head to head with M4 Max, 128 gigabytes. So I thought that was interesting to point out. All right, guys, we learned how to take this Silicon Valley disrupting miracle of a technology, DeepSeek R1, and take control of that power ourselves. We learned how to install it on our own computer, and we got to see a real-world comparison of it running in real time from a $5,000 computer to a $1,000 computer. So what did you think? Do you think it's worth it to upgrade to the $5,000 M4 Max? Or do you think, running the 7B is already plenty of intelligence on a MacBook Air M1? Let me know in the comments below. If you want to be notified about more practical AI tutorials, don't forget to hit like, hit subscribe, hit the notification bell. That's it for now, and I'll see you in the next video.
Nomaditsu.